Welcome to another problem about pumping liquids out of tanks. In this case, we have an underground cylindrical tank. It's 27 feet tall and 16 feet in diameter and is filled with water. If you've watched already the conical problem, you'll notice one change is not only that it's a cylinder, but this time we're measuring everything in feet. This tank also has a spout on top that's 3 feet tall, and the water is going to be pumped through that spout. We're also told that water has a density of 62 pounds per cubic feet, and we want to know how much work is done in pumping all of the water out. Now, just like we did in our last problem, we're going to want to start this one with finding a sample cross-section. So I'm just going to draw this in the middle, and we're going to state the thickness of this to be delta H. And we're going to let the distance h be up to that sample section. So our very first step in the process is to come up with our formula for the volume of our cross section. Now this one's a little easier because our radius is constant all the way up. So when we do pi times r squared, our r is actually 8 squared, and our height on this cylinder, the cross section that is delta H. And so we have a nice little expression for the volume, and our units here are going to be cubic feet. We see that cubic feet in the denominator for our density, so we quickly see that when we want to change and multiply by the density, we've got 62.4 pounds per cubic feet. And we multiply this by our 64 pi delta H cubic feet. Nicely, the cubic feet cancel out. But what does this equal? Unlike the last time where we had kilograms and we labeled it as mass, this time this isn't mass because this is measured in pounds, and so we've already jumped to where we have force. Pounds are a measure of force. And before I forget, remember everything we're doing here is just for one slice. So the volume of one slice and the force on one slice. Now to figure out work, we know that we have to take force times distance. So we need to figure out the distance that one slice is going to have to travel. And so we go back to our diagram and we see that our slice is right here, has to go all the way to the top of the spout. So we're going to be looking at pumping that slice that distance. And so if we take the height of the tank plus the spout, we get 30 feet. And so this distance right here is going to be 30 minus h. And so our distance is 30 minus h, and that'll be measured in feet. So now we're actually already ready to set up our integral. And, oops. Oh, there we go. Sorry for the delay there. And we want to go ahead and put all of our constants out front. So we've got 62.4 times 64 pi. That was measured in pounds, and we also have a dH on the end left from our force measured in pounds. And then we're going to multiply that times the distance, which is 30 minus h. And that's measured in feet, and so we know our answer is going to be foot-pounds, which is a measure of work. We should label that at the front here, so this is work equals. And now we just need to figure out what our limits are going to be. So we take a look at our cross sections, and we can see that the lowest cross section is going to be down here at 0. And the highest one is going to go right up to the top of the tank here at 27. And so we see that our integral is going to go from 0 to 27. And the last thing we're going to do is put this in our calculator. And when we do, we will get the answer of 5,589,361 foot-pounds.